Hello, welcome to Explore Classroom. My name is Kip Hopman, and I am so glad you're joining us today. Here in the United States, we are celebrating Women's History Month. From the women who have made history in the past, the women in your life today, and the young women watching today's show, we see you. We encourage our viewers to check out biographies about women, including our very own explorers, like Dr. Alicia Adewale and Florence Goupil, to learn from their legacy. Today also marks Holi, a national Hindu-based holiday celebrated in India, Nepal, and several other countries. Learn more about these important celebrations at nationalgeographic.org. At National Geographic, we use the power of science, exploration, education, and storytelling to illuminate and protect the wonder of our world. Explore Classroom connects students worldwide with our National Geographic explorers for short lessons and time for your questions. Today's session is a collaboration with National Geographic Learning, a part of Cengage Group. Together, we are dedicated to reaching new audiences with Explore Classroom. And I am so glad you're joining us today for our second event in a 4-event special series for high school students that will take place this spring. Today, our explorer is none other than the amazing Keolu Fox, a geneticist who combines science, history, and culture by using human genome data to understand the past and build a better future. Today, Keolu will share how his work in genetics provides knowledge of Indigenous history and helps pave new ways forward in medicine and beyond. But before we get into today's lesson, I'd love to welcome our registered viewers who join us from around the globe. Special shout outs for today go to New Mexico School for the Arts, Syracuse City School District, Ram High School, Butler Senior High School, Avison Global Leadership Academy, Windy Ridge School, and all the home schools out there. We are thrilled to have y'all here. And with that, let's get this Explorer Classroom started. It's time to turn it over to Keolu to share all about decoding Indigenous history. Take it away, Keolu.
Yes, aloha everybody, and mahalo to Kip and the National Geographic Society and all of the young, beautiful minds that are joining us from all over the world. Special shout out to everyone who's joining from Ukraine. I can't imagine what many of you are going through, and it is an extreme honor and privilege to get to talk to you about my work and a lot of the things that we do just kind of from the day to day in our National Geographic Society. And without further ado, I am going to share my screen and we are going to go on a journey through the Pacific. So let me do that. And let us begin. Okay. How does that look? Can you guys see it well? Yeah, thumbs up. Cool. All right, as Kip queued us up, we're going to be talking about decoding Indigenous history today. I am a genome scientist, and for those who are not familiar with what that means, it means that at some point in 2003, we were able to sequence the human genome for the first time. And to parse and mine large quantities of data that represent our genealogies, we were able to use computer science to kind of automate and increase the throughput of many of those methods. And I'm happy to answer any questions you have about that stuff. My focus is really on genome sequencing technology and genome editing technologies. But today we're going to talk about how we use these tools to understand where people came from. How do we create higher resolution sort of understanding of our diaspora and our migratory history? And it's a really special and important thing for Hawaiian people for a number of reasons, which I am a part of, and I'll kind of get to that and what that means. Being the first person from my community to earn a PhD or a doctorate in genome sciences. And I want to talk a little bit about that. First, though, day to day, guys, I am a professor. I work at the University of California, San Diego, And when you guys choose where you go to school, make sure you choose good places to live, because my school is perennially ranked #1 by Surfer Magazine. We are a really unique place in terms of the types of research we do, but it's also important to have a balance in your life. And it's a lovely place to work, and I'm happy to talk about that. We have created the world's first Indigenous Futures Institute, where we prioritize the will of Indigenous people, the sovereignty of Indigenous people, and we think about everything from architecture to education to medicine to mathematics to coding in ways that we can utilize cutting-edge technologies to empower Indigenous communities. I come from a community of Indigenous futurists in Hawaii. For example, we created some of the first color newspapers in the world. We had electricity in Iolani Palace well before the White House. And we actually created universal health care. And these are some really, really interesting things. But the reason I'm showing you this is because I kind of want to break down or dissolve your opinion of Indigenous people as relics or people who are helpless and need aid. We are very much into emerging technologies and using them to support and empower our communities. Hawaii, though, is by all metrics one of the most remote places in the world. Take a look at this. This is National Geographic, baby, so we're going to be looking at a lot of maps today. And you can see that we have Hawaii square in the middle of the Pacific Ocean. And it is really, really interesting to think about how people got there. You know, how did the first people, the Indigenous people, arrive in a place that is so remote in the world's largest and most ancient ocean? I am from the northern tip of the Big Island of Hawaii, and this is a valley called Pololu. It's a really beautiful place, really good diving, fishing, surfing, and it is one of the only places in the world where you can snowboard and surf without a wetsuit in the same day. We have 11 out of 13 biomes on planet Earth. It is one of the most biologically diverse places on planet Earth. We have some of the most diverse soil profiles. Here you can see a green sand beach, which is filled with lovely olivine. But we also have a really complex history with militarism, imperialism, colonialism. And because of some of these things and the climate change that the world is feeling right now, we are also the extinction capital and the invasive species capital of the world. And for those reasons, it's a very complex place in terms of any way you think about nature and biology. We are also the most diverse place in America for human beings, that is. 4 of Hawaii's counties are ranked amongst the most diverse communities of people in America. And you can see Hawaii County, where I'm from, is the most diverse county in America. We have diverse communities of people that have been arriving in Hawaii as an island for the last, 2,000 years. So we have been mixing our genomes and sharing our genealogies, and it represents a really interesting place for that reason. For example, Kohala, where I'm from, has a lot of people from different parts of the world. And here, I put this picture here because, are these guys cowboys or Indians? Both, neither. I think it's really important to think about that. And this is Ikua Purdy, and he's one of the most famous cowboys in human history that you've never heard of. But thinking about the ways that we deconstruct the bias that we have around who people are and what they do is really, really important. So I wanted to show you that. Kohala is a really beautiful place if you ever get to make it out there. But that brings us to the question of how we arrived in a place that is so remote. When did it happen? And how do we know that those time estimates are accurate? And one of the things I want to work with you guys to do is thinking about all of the different ways that you question things and how we prioritize and ask questions. So here's a map. It's representing the Pacific Ocean. We can see something called the Polynesian Triangle, where we have Hawaii on the top, and it says that it was settled about 900 years ago, versus Aotearoa, or New Zealand, which is the colonial name for Aotearoa, where the Maori come from. and that is over here. And you can see it's settled around 1,200 years ago. And then Rapa Nui, or the colonial name for that, is Easter Island. And you can see that that happened. And what I want you guys to focus on here for today is that what Master Navigator Nainoa Thompson always calls the original moonshot, happened out of Asia about 3,000 years ago, or probably earlier than that. And then into the Philippines, and then from the Philippines into what we call the Bismarck Archipelago, and then into what we call remote Oceania, which is a place where you have island nations like Samoa, Tonga, Rarotonga, Tahiti, which we will talk about today, and then into these other more remote places like Hawaii. And our ancestors used some pretty amazing technologies to do this. They utilized the stars at night. If you've ever seen Moana, the movie from Disney, there's a big theme in there. They utilized ecological metadata like bird migration patterns and different fish patterns and sea currents and wind patterns and all of these different types of data to come up with safe voyaging patterns back and forth dynamically through the largest ocean in the world. And I know we have a lot of people from Europe joining us today. You can imagine that traveling in the space of the territory of Europe plus Asia in less than 1,000 years is a really impressive thing to do. And a lot of these wayfinders, they would memorize those star paths and the locations of many of those islands. And I have a map here. This is from the Marshall Islands, and you can see this is made out of coconut husk and popsicle sticks, and it has a whole bunch of different little cowrie shells and the names of those individual islands. So a map like this would be memorized before you got on your double-hulled va'a, or voyaging canoe, in pursuit of finding new places. So where did these time estimates come from, and how do we know that? So let's dig into that. A lot of the times you'll hear different investigators using things like archaeological data, like here on Rapa Nui, or linguistic data. Let me give you an example. We say aloha in Hawaii. In Samoa, they say talofa. In Aotearoa, or the Maori, say aroha. And so they're similar versions of a word, but they're quite different. Then there are other words that are similar in every language. For example, moana means the ocean in pretty much every Polynesian language. Manu means bird. And the reason for that is those things were probably central to our navigation and migratory history within the world's largest ocean. Then we get to some more complicated ways of thinking about this, a little more futuristic. One of them is applied mathematics and using simulations to understand and predict and account for many different variables within the Pacific, followed by genetics. And that is my heart, and my discipline that I've focused on is decoding the human genome to understand our diaspora and migratory history throughout the Pacific. And another person that arrived in the Pacific and was really interested in understanding how we arrived there was Captain Cook. And he arrived there to focus on science as well, to perform and bring scientists to observe something called the transit of Venus. And the transit of Venus is essentially watching the transit of Venus across the surface of the sun. And at the time, this was a really important piece of data to collect hundreds of years ago to understand where time starts and where it begins, and many other kind of celestial features that would come from collecting that data. In the process of that, though, Captain Cook would work as a cartographer, a person who was a really detailed map maker of the time. He was probably one of the best people in the world at that time. He is renowned as being probably one of the most famous and great navigators of his day. And here are a look at some of those notes. And this is a painting of what that initial moment of first contact between indigenous people and people from the Royal Navy probably looked like. You can see these voyaging canoes of our Native Hawaiian ancestors and the HMS Resolution in its arrival there in Kealakekua Bay in Hawaii. And it started off as a partnership and a friendship. But this is how it ended. It ended violently. And this is something that has happened throughout history. There were miscommunications, and there were probably problems with dialogue and intention, and sowing the seeds of imperialism and colonialism. But before Cook passed away in Hawaii, he ended up in Tahiti, in an island called Raiatea. And I've focused in on that using Google Maps, and you can see Raiatea right here looking beautiful. This is a place of incredible beauty and ecological diversity as well. You can see the Tapu Tapu Atea Marae, one of the most famous archaeological sites in the Pacific. And here's just a beautiful look at Raiatea with its healthy, beautiful lagoons and reefs. And in Raiatea and Tahiti, Cook would run into this man by the name of Tupaia, the most famous navigator you've never heard of. And that is because Tupaia was Cook's golden goose. He was a person who was by all means what we would consider today a genius. He was a master sailor. He was an artist. He was a politician. He was a priest. He learned English in less than a year. And he was able to communicate and help guide Captain Cook as a navigator to places like Australia and Aotearoa, New Zealand, and many other far-flung island archipelagos in the Pacific. It is said that he had memorized over 1,000 locations of different islands as a navigator and a sailor. He was also an artist, and here are some of the art that he created using watercolors. Look, I'm not a good artist, but I can't imagine creating something like this the first time I'm using watercolors, okay? But here is a map that they created together, Cook and Tupaia, two master navigators with totally different ways of viewing the world, viewing space differently, viewing time differently, communicating in different languages, creating a true partnership that represented many of the different places that existed in the Pacific. This is one of the most famous maps ever produced, and it was in partnership between a Tahitian man and a man from the English Empire, which shows us that it is possible to have equitable partnerships between scientists today. One of the second questions we need to ask is how we know which direction this diaspora, this original moonshot came from, because here it's represented and you see and I'm asking the question, which direction did my ancestors depart from? Did they in fact depart out of Taiwan and into the Bismarck Archipelago and then into the deep Pacific? Or did they come from the other direction, which would have been South America? Now, in the 1940s, it was believed by everyone that the trajectory happened from the other direction. And this man, Thor Heyerdahl, was central to populating that narrative, that theme. And the reason I bring this to your attention is because I want you all to think about who's in control of the narratives and the way that we believe science to work. Who's biasing data? Because for a long time, without consulting with Polynesian and islander people, the rest of the world believed that Polynesia and the most isolated places in the world were discovered from the wrong direction. So who's biasing that data, and where does that come from? And then whose hypotheses are we testing as scientists? And finally, you need to deeply consider this question. Is it even your question to ask? And I'll let you think about those things, but let's think about what happened with Thor Heyerdahl. Thor believed, again, that this diaspora occurred out of South America and then drifting helplessly into French Polynesia, the Marquesas, etc. He popularized a book called Kon-Tiki, which is extremely famous. They made a documentary. Here's him looking very serious on a floating raft. And then here's him crashing and needing to be saved because he was dead wrong. And it's okay to be wrong. And this is also the birth of something called experimental archaeology, this movement. And you have to admit, you have to be really brave to get on a boat at this time like this and sail from one direction in an attempt to prove something. And it wasn't until 1978 when our community participated in something called experimental archaeology by building this extremely famous voyaging canoe called the Hokulea. And at that time, it was illegal to speak Hawaiian in Hawaii. Our culture was on life support because of colonialism and imperialism. And this moment would become the moment of cultural renaissance. Our community was so over the moon excited that we were able to sail in a boat that we engineered in the spirit of our ancestors from Hawaii to Tahiti using no modern technology, GPS, all of that stuff, even at the time, the equivalent that exists in the 1970s. And this photo on the left is one of my favorite photos. It is a photo of our community's arrival in Tahiti. And you can look at the sheer joy in everybody's face, proving that that was indeed the direction that we came from. And that brings us to a saying that we have in Hawaii and Tahiti and New Zealand. And that saying is, Ika wama mua ka wama hope. And that means walking backwards into the future, taking advice from your ancestors. And in the spirit of Ika wama mua ka wama hope, it felt really good as a geneticist, as a Hawaiian geneticist, to get to utilize the genome sequence data from modern Polynesian communities to refine the paths and the timing of the peopling of Polynesia, to confirm the estimates that our experimental archaeologists in the Hokulea came up with, and to understand this in an empirical way and present that to the rest of the world in one of the most famous scientific journals. And if you'll look closely, you can see that we were able to use our own language. We were able to use and represent Hawaiian, Tahitian, Samoan, and many of the languages and the place names that we call our islands for the first time. But that doesn't mean the media is going to get it right, okay? We can't control what the media does a lot of the time. And they said, no one could have predicted DNA offers surprises on how Polynesia was settled. Well, guys, that's not really true. We've known that for thousands of years. We knew the directionality. We had time estimates, but you have to understand that the media sometimes has an agenda. So again, ask questions about what you read. And so if you're not happy with the way the media kind of accounts for something, sometimes if you want it done right, you got to do it yourself. So I wrote this piece for Scientific American where I said, genomes show the history and travels of indigenous peoples. A new study demonstrates Ika wama mua ka wama hope, or the future is in the past. And that's important, again, because we get to use our language in Scientific American and demonstrate and sort of distill the data we collected to the non-technical public. And here is a photo of our boat, Kiakahi, docked in Keaukaha. And this is a boat that we regularly take children that are your age out to learn sailing in Hawaii. And that brings us to why we need to really think about how much bias can be presented in or reproduced in different types of data science. And I wanted to point you in this direction. This is a summary of every single genome study that has occurred. And it was recently updated in January, as you can see. And you can see that 95% of genome studies have exclusively featured individuals of Western European ancestry. And if you think about genomics as the future of medicine, then this is not an accurate representation of the diversity that we see every day in every classroom all over the world. This is basically stacking the deck for one community of people to benefit from the next generation of medicine. But what's more concerning is that 72% of these studies have taken place in 3 countries. And I want you guys to think about why that's dangerous. That's dangerous because that means that only 3 countries are in control of that data, in control of that narrative, and we need to correct those things. So I want to explain some of the things we're doing to shift these numbers in the direction of equitable data science. And that is why data sovereignty is so important. It's important to think about data sovereignty. And data is actually a hard word to define. Data are things that are known or assumed as facts, making the basis of reasoning or calculations. And sovereignty is often aligned with nationalism. It's a very complicated idea. Sometimes people refer to this as supreme power or authority. I prefer the other definition, which is a self-governing state. And you have to think about who's in control of your data. If it's your genome and it represents your genealogy, that should be yours. You should have autonomy and decision-making process over that information, especially in a world where data is the world's #1 resource. In 2018, data surpassed oil as the #1 resource. And if I'm going to leave you with anything, I want it to be that data should be compared to things like water, oil, rare earth minerals, timber, and many other things. And it is a precious resource that we should think deeply about before sharing it and giving other people access to it. It is very valuable, especially in health settings. 23andMe, for example, which is a company that likes to sequence or analyze people's genomes, sold access to their database to GlaxoSmithKline, a large pharmaceutical company, for $300 million. So it's very valuable. And the value of it is on the rise. So what is the future of protecting that data and sharing it in equitable ways? Well, we have to think about it like vertical integration of technologies. If you look closely here, you can see that Henry Ford, when they were coming up with the development of the Model T, which is the first automobile that revolutionized transportation, knew this, and he was in complete control of all of the assets that went into the development of cars. Leather for the seats, rubber, where he bought plantations that he ran in the Amazon, and ball bearings and other steel parts and components that all went into the standardization of these vehicles. Amazon.com is doing this with respect to data. They're thinking about processing data on the cloud and owning and having access to that information. And that is testament to why they are the largest company and corporation on planet Earth, because they know data is king. Inspired by that, myself and colleagues started the first human genome sequencing research institute and data repository and biobank on a reservation here in the United States of America. And this was unprecedented at the time and a lot of fun. And then we were inspired by the vertical integration and being in control of our data. We also started Variant Bio, which is a company that gives proceeds of the things that we create back to people so that they're partners in and not subjects of genetic research. We also provide them with free access to the treatments that we create because that's the right thing to do. In the end, there is no substitute for grassroots research and democratizing technology, bringing technology to the people to sort of de-black box how things work and make it more transparent. And we are thinking about ways to bring research capacity to the most remote places in the world by including a lot of the tools we need for genome sciences in shipping containers and things like this. And this is the beginning of our new Holo Health program, bringing science and those tools to the most remote places in the world. If you want to learn more about this, you can check out the National Geographic Overheard. We did a podcast and it was called Wayfinding Through the Genome. And I am happy to take your questions. But first, I encourage all of you, if you have projects that are focused on Indigenous futurism and climate resilience amongst your classrooms, and you want to apply for seed funding and small grants, please apply here at experiment.com grants/IF. And I want to thank many of our different sponsors for the opportunity. And I'm looking forward to hearing from all of you. I hope that's helpful.
Definitely helpful, friend. All these answers have been so informative, and we can't thank you enough, truly. And I love that you mentioned, you're so inspired by the youth, as they are the future change makers, the ones who will help, as you open these doors, pave the way. And just such a wonderful show. We truly appreciate you, Keolu, and also to all the students and teachers watching. We hope you all join many more of our events. And our next event, in partnership with National Geographic Learning for ages 13 to 18, will be on Wednesday, April 12th. Join explorer and deep sea biologist Diva Aman to learn all about the weird and wonderful animals living in our underwater habitats. So go ahead and register for this event and more at natgeoed.org/Explore Classroom. You can request a chance to be featured on screen as well. And fellow teachers, we've also created a new interactive guide for you to share with your students to take them on a learning journey with each of our special guests. Find the Explorer Mindset in Action Guide and Teacher Edition linked on each event registration page and also in our YouTube chat bar. Have a great day, everyone. Stay curious and keep exploring. Bye now.